So we talked about empirical, which was actual data. Well, you don't always have actual data, right? So the other way to compute a probability is with the classical method. All right. So this is not actual data, but I'm looking at this and I'm going to say this is the number of ways it can occur. Number of ways E can occur over the number of possible outcomes. We do this more often because we're saying, okay, so what's the likelihood that this could happen? Another way to write this is the number of times E occurs out of the number that's in the sample space. See where these variables are coming back? I told you they would. Here they are. This is the number of outcomes in E over this S. I just want to look at this number of outcomes in the sample space. I just want you to see where these variables are coming in because they are used. All right. Here's the kicker to this one. So the empirical is where you have actual data. The classical method here is theoretical. All right. Theoretical. Saying, how many times could this occur based on how many options I have available to me? All right. So look at example 5. I put this graphic in here just so that we can see all of our options available. So I roll a pair of fair dice, which means that anything could happen there, right? That's a fair dice that I'm looking at. So if I roll them, I could get a 1 and a 1. I could get a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, and a 6 and 1. Do you see how this is all playing out? Okay, so I want to compute the probability of rolling a 7. In order to do probability of anything, it's part out of whole. So the probability of rolling a 7, right, is going to be how many 7s I get out of my total number. Well, let's look at this. How many total number do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What's 6 times 6? Yes, so I have 36 total outcomes. Now, because this is a graphic in our book, this is all the possibilities that are available, and the ones that we're looking for here are already in red, right? I can roll a 6 and a 1. I could roll a 5 and a 2, a 4 and a 3. The other dice could be a 3 and a 4, a 2 and a 5, or a 1 and a 6. So how many possibilities do we have there? 1, 2, 3, 4, 5, 6 possibilities out of how many? 36 total. And you can write that as 1/6. Because remember, we said a probability could be a fraction as long as it's between 0 and 1, still a probability, or a decimal. This one we're just going to choose to leave as a fraction. All right. Okay. What's the probability of rolling snake eyes? Have you heard of that before? Snake eyes. That's a fancy way to say. That's compute the probability of rolling a 2. So the only time we can ever get a 2 is if it's a 1-1, right? So how many options can I roll a 1 and a 1? Once. Let me scoot this up. So the probability of rolling snake eyes sounds so like Vegas, right? Is 1 out of 36. Is there anything I can do to reduce that fraction? Negatory, good buddy. So 1 out of 36 is the probability I can get for rolling those snake eyes. Nice. So now comment on the likelihood of rolling a 7 versus rolling a 2, which the 2 is the snake eyes, right? So look at that. What's the probability of rolling a 7? Let's leave it in terms of 36 because we can compare that easier. Probability of rolling a 2. Rolling is 1 out of 36. So this means you are 6 times more likely to roll a 7, right? Because if I'm looking at this, you get 6 choices here, you only get 1 choice here. So 6 times more likely you are 6 times more likely to roll a 7 than a 2, right? That's the key. All right, probability. Seeing what's available. Now, we didn't roll, did we? We didn't do an experiment by rolling these dice. No, this is the classical method because this is theoretical. Saying this is what could happen here based on all of the information that I have. That's 2 different types, and we're looking at comparing those two.